Hi girls, so I gave you this question here for homework tonight, and it's whereby we were kind of just working on some of the things that we were working in class today about the rotation of solids, okay? Excuse me. So this question here, it says, the base of a hexagonal prism shown is tilted at 30 degrees to the horizontal plane and is 60 millimeters in height. So you can see here, if the prism was standing upright, this is what it would look like. So starting with a vertical line, I'm just going to go up here. I should have labelled before I start, but that's okay. I'll do my indexing after. Excuse me. And it is 60 millimeters in height. So from the XY line, you can see here, I'm putting my 10 on the XY line, marking up as far as the 16. Okay. Project my line across. That is what the pyramid would look like in elevation. So I'm going to go A, B, I'll call this C, D, E, and F. Now, A and B will be here in the plan, so I'm going to go BA because that's how I see it first. Then I have C and F, C comma F, and I see D first before I see E when I'm looking at the elevation. So I have A, B, this is C, this is D, and if you want, look, I'm just going to pop in some colour here, look, orange face, every second one, blue face, and so on. You get the idea. Okay, and look, we'll go with a yellow for the top and a yellow for the base. Now, just to help us with a little bit of our colour coding, edge A, I'm going to pop it up here, there's B, C, D, E, and F. Okay, so there's my points. So edge for A and B is here, C and F, and so on. Now, what it does is it tells us here, the base of it is shown below, and it has to be tilted at 30 degrees to the horizontal plane. Now, we learned about this today in class. This is our XY line. The horizontal plane is representing the ground in elevation. Okay, so the XY line is representing the ground in elevation, which is the horizontal plane. In the plan, if you remember in class today, the XY line in the plan view is representing the wall. It's like my phone is there and that's the wall, and obviously the object will be here and the wall will be here. In elevation, that wall is just folded down. That's the idea. Okay, so what do we want to do? We want to tilt it at an angle of 30 degrees. So AB is going to be your hinge. The plan shows the base of the prism when resting on the HP, the horizontal plane. Draw the plan, elevation and end view, end elevation of the prism when it is rotated about AB. So AB is here. I'm going to rotate it at 30 degrees. Okay, that's the angle it makes. So that's all I have to do there. However, because AB is my hinge, everything else is going to rotate as well. So I take AB and D and E is going to rotate. Now don't forget about the other points. So that's D and E, but also rotating is C and F. And you can see the two of them have rotated up to their new position. So I'm going to heavy that in now, because that will be there. Okay, so that is the new position of D and E. And then I've got C and F. Okay, now, really handy little trick here, I find it is, because we already have the base, it's just a case of going perpendicular, because the initial relationship was a horizontal line and vertical lines. Now it's a 30 degree line, so 30 plus what makes 90? 60 degrees. So if you go at 60 degrees like this, 60 degrees from C and F, and 60 degrees from A and B, somewhere up along there. Now the height is 60, so there's two ways we could do it here. I could take the height from here, D and E, take that height on my compass, and then go up to the new position for D and E and just mark it for C and F and mark it. Alternatively, I could take my compass and put it on A and B, and just go to the edge where it would have been up here at the top, just to show you. I could rotate that. Now I need to extend my line a little bit there, apologies. Just extend that a little bit. So as you can see, everything rotates about A and B. So the top point will rotate. And I could rotate the rest of them, but I'm just going to look at the relationships of the lines. Now I'm going to just check my accuracy here. I'm going to take the height just to see how close I was. I'm going to take that height on my compass, the 60, put it on here. And you can see, that's pretty bang on. Maybe a half a mil in the difference. But the easiest thing to do here now is 30 degrees once again, working downwards. And that is my prism in elevation. So that's what the elevation looks like. And remember now, it's a hexagon on the top as it is the bottom. So that's the elevation done. Now what I want to do is I want to start the plan. So A, B, C and D in the plan have all obviously tilted up except for A, B, that stays in the same position. But when I look down the top of it, I'm actually going to see this face and I won't see the bottom face. So I need to draw the new plan in its new position. Bring this down, and this down. Now I mentioned this today in class. Those arcs, you want to put them in a different colour. I'm just going to highlight them in green. See these arcs here? Even that arc. Okay. What do those arcs represent in plan? Even though they're arcs in elevation, in plan they will appear as horizontal lines because the object is just tilting backwards. Like we were in class today, the object is tilting backwards. As it tilts backwards in elevation, it looks like an arc of a circle, but in that plan, that arc would just follow a straight line. Okay? So, what do I want to do? From A, I'm going to come across to represent those arcs. Same from F, excuse me, same from B and D, and same from C. Now, I'm going to locate those points. So, position here, if you follow this guy down, well, that's going to be a position right there and there. Looks like they're actually in the same position. Then the ones in the middle are the same with F and here. Okay, I'm going to draw that in as best I can, nice and quick. Excuse me. Okay, so there is my top surface. That's just the top. Now I have to do the sides going down. So the sides will go down as far as here. And here. Pop in the colours in a second. Like this just with our visualization. Happy with that. Just taking in my lines there. Excuse me. There we go. And then I'd have a little bit of hidden detail. There to there. There to there. And the edges running down the back, there would be, because that's the rectangular faces on the outside. There we go. So that's what it looks like. Now, if I was to pop in some colour there, we'll get onto the end view in a second, the end elevation. There's the yellow surface for the top. Then I have to think about these guys, CD. So the CD guy, it's this guy. He's on the outside, so that's orange. I've got an orange one here as well. And obviously we got blue in here. Okay, on this side, so C and D. This one, there's orange. And there's the blue. Every second face, that's from BC, the edge. Okay. Okay, so that's it starting to take shape. Now that we've got the elevation and plan done, let's get the end elevation done. So from here, follow it down 45 degrees. Guys will come across and across and across. Technically there's 12 points altogether on this guy. 6 at the top, 6 at the bottom. Over, up, up, and up. And then these three guys, these guys at the bottom, it's just going to be a hexagon at the bottom and a hexagon at the top. But what's important is what goes in as hidden detail. Okay, so the 6 points at the bottom are here. 1, 2, 3, 4, 5, 6. Same thing at the top. 2, 3, 4, 5, 6. Now, what do we have in? I want to start with the rectangles. Okay, when I'm looking at it from the side, I can definitely see underneath the object. I actually can't see the back of it at the top. So this bottom part is actually going to be fully heavy. you go. And then that's what I'll actually see. Now, as always, bit of hidden detail. This is orthographic projection. Okay, and then I'd have the edge that runs down the back here, hidden detail in there, and in there. And once again, I said yellow for the top and the bottom, so I'm just popping in my yellow there. Okay, and then looking at the front of it, I think this is blue first, in the middle. Yeah. And there you go, guys. Now I'm really quickly just going to refer to the DCG solutions, just to make sure that I'm happy. There we go. That's what the object looks like. Now if I use my indexing, well, I should have had the points labeled up here as well. BA, C, F, D, E. Oh, geez, so I had A, B. So that would have been A, B, C, D, E, F again. Okay, if I was to label those, there's F, there's C. I've got D and E here, and then I've got A and B. Sorry, A there, B here. Okay, the same thing here, A and B, C, D, E, F. Okay, so there we go. Now, if I just quickly refer out to the DCG solutions. Bear with me now, guys. Okay, so orthographic projection, rotation of solids, go full screen mode there. Rotations, we did these in class, so did this one, here we go. Start with this guy, there it is, 60 degrees rotated, you can see the rotation there. Got that guy. Now, for some reason, mine is definitely out of kilter. I'm assuming it's a mistake actually in this guy. Maybe it's the angle that's actually wrong on this guy, maybe. Looks a bit small there. But the method is right. If you look at there, as you can see the hidden detail here. Okay, unless I did something wrong. Oh, I'm some idiot. That's my bad. Sorry guys, that's actually my bad. I forgot to bring this down. Total error there. That should have gone down there. I'm just realising. And that should have gone to there. Stupid. Sorry there. No guys, after messing up the whole sheet, at least I fixed my error, well, found my error. That should have gone to there. Sorry, should have gone to here. Can't believe I did that now. And yeah, that should have been the triangle there. Yep, but I think that it should sit on top of it anyway by the looks of it. Going off the DCG solutions, looks a little bit funny. Okay, anyway, continue on. This is what we end up getting. Yeah, that looks similar to what I had there in the end elevation. It was just the case, guys. I think I made a small error there. Apologies for that, okay? But you get the idea. It shouldn't have been that long. Apologies. I forgot to bring this guy down now that I had it. I brought the ones on top down. Yeah, and it ends up on the same line as AB, looking at that. Yeah, just going to check that now. 60 mil. Yeah, there's nothing wrong with that. I think there's probably a mistake in the book in regards maybe the angle she did, but I made a mistake here. So there you go, guys. Anyway, look, that's the homework question. I hope you found it helpful. Apologies there for the error on my part. I should have, this point here should have been brought down. So D and E, that's actually not position of D. This is the position of D. This is the position of E right here. And C and F weren't here. They were actually over about a mil or a mil and a half then to the right, maybe 2 millimeters. C wasn't here, it was actually here. Okay, so apologies for that, guys. But that's it there done. Hope you find that helpful.